So by now, if you've seen a pattern, because what's really sticking out here is the 49. What this log expression here is saying is 7 raised to what power is going to give me 1 over 49. And we know, if we just wanted 49, we know 7 squared would be 49. So by now, if you've noticed, when it's in this kind of a format with fractions and whatnot, it's just going to be negative of what your answer was. So the answer to this would be negative 2, because if we had 7 squared, that would give us 49, but we want the reciprocal of that, so we just apply a negative exponent, and that would cause the exponent to be positive on the bottom, and that would give us what we're looking for, 1 over 49. So when I raised 7 to the negative 2 power, I got what I was looking for. So in this case, x is equal to negative 2. If you want to look at it the exponential form way, and the answer is negative 2 here. It makes sense anyways, right? Because logs spit out exponents, and we were looking for an exponent here. So either way, it's negative 2. Okay, so why don't you go ahead and try another one with the fractions, and I'll go over it with you. So now here we got a base as a fraction and an argument as a fraction. We haven't seen that before, but we're just going to stick to what we know and see how this goes. So what this log expression is saying, if I wanted to switch from log form to exponential form, and I know this thing's going to spit out an exponent, right? So I don't know what that exponent is right now, because that's what logs do, they spit out exponents. But what this is saying in exponential form is 2/3 raised to what power is going to give me 3/2, which is just the reciprocal of 2/3, right? Okay, so if I have 2/3 here, and basically what I want is just to raise it to an exponent that pretty much just makes it flip, right? So that's just going to come from our negative exponent laws. If I were to raise this to the negative 1 power, it would cause it to flip, because this negative would get distributed to the top and bottom. Get 2 to the negative 1 power, 3 to the negative 1 power, right? And then a negative exponent is a positive on the bottom, and the negative exponent on the bottom is a positive on top. I think I'm explaining this too much, but you end up getting 3/2, just because we remember from our exponent laws, if you have a to the b, and that's raised to the negative 1 power, that's equivalent to b over a. So our exponent that we are looking for, and that the log is going to evaluate for us, we saw that it is negative 1. So x would equal negative 1. Okay, so here's another one. What's interesting about this one is that we have 0 as the argument. So I see log here, so I know eventually this thing is going to spit out an exponent. But what this is saying is 3 to what power is going to give me 0. So we go ahead and just analyze that for a second. There's really no power you could raise 3 to get 0. If we raise 3 to 1, we'd get 3. If we raise 3 to 0, we'd get 1. I mean, there's really no way about it. So just thinking logically, when you raise stuff to an exponent, you got to get something out. You never get 0 out. So there's actually not an answer for this. And later we will see graphically why you can't take the log of 0 or anything less than that. So in the beginning, I believe I said you can't have anything negative in the argument. Well, you also can't have 0 in there. So I guess this is a special case, and there's no answer for this. Okay, just another example here. What sticks out about this one is you have a negative inside the argument, and in the beginning of the video, we already mentioned that you couldn't have a negative inside the argument for a log. That's just something we can't have. We'll see graphically why later, but just investigate this a little bit if we want. This is saying give me an exponent. That's what logs do. And if we were to write this in exponential form, it's saying 3 to what power gives me -9. And, when you raise something to a power, you never get a negative out. So, I guess that's a good enough reason for us just to accept, for now, just algebraically, why you can't have a negative inside the argument. So this is another one that we don't have an answer for. So we can't evaluate this. Okay, so here's another one. Log of some stuff. So we know it's going to spit out an exponent. And what this is really saying is 3 to what power is going to give me 15. So remember we said how we're going to do some log stuff by hand, or we might have to use a calculator. This turns out to be the calculator case. You have to use the calculator because you come off to the side and you're like, okay, 3 to the power of 2 gives me 9, but that's not enough. So then you're like, let's try 3. 3 to the third power, that's 27, and that's too much. So then your answer is going to lie somewhere in between 2 and 3. It's going to be 2 point something. So I can't think of that off the top of my head, so we're going to have to use a calculator. Okay, so we're going to have to resort to using a calculator here. But most calculators only come with a common base of 10. So that's not going to be useful for us here because we have a base of 3. So we're going to resort to the change of base formula, which states that if you have log with a base of a and a argument of b, then that is equivalent to log of b divided by log of a. So we could use that for our advantage here. So this is going to become, using that change of base formula, it's going to become the log of our argument divided by the log of our base. And make sure not to make an algebraic mistake here. This is not the same as log of 15 divided by 3, or to try to reduce this to be 5 or something. You have to input this on the calculator individually, log 15, enter, and then divide that by log 3. So let's see what I get when I do that. So I'm going to press log 15 divided by log 3, and I got approximately 2.46. And I just rounded off, so you're going to be asked to round off to however many decimal places they ask you to. Okay, so another one that we're going to have to use a calculator for, because what this is saying is 2 to what power is going to give me 17, and this log is going to go ahead and spit out an exponent. It's just that exponent doesn't happen to be a nice looking number. So we're going to use our calculator, and remember from the change of base formula that we could do this with it. So here, we're going to rewrite this as, going to apply this to it, the change of base formula. So we're going to get the log of the argument divided by the log of the base. And then we just input this into our calculator individually. We're not going to think that we could combine the arguments or anything like that. So log 17 divided by log 2. I got approximately 4.1, and I rounded that off. So the exponent that this will approximately spit out is 4.1. Okay, so why don't you guys go ahead and give this a shot, and then I'll go over it with you. Got this because I know I'm going to have to use my calculator because, second power would give me 36, but this isn't 36, it's 35. So I know it's going to be some long looking decimal type answer. So I'm going to apply, whenever I use my calculator, I'm going to apply the change in base formula to it. So this would become log of 35 divided by log of 6. And I just enter those individually into my calculator and see what kind of answer I get and round. We're just going with the flow with this right now. So log 35 divided by log of 6. I'll just go with 1.98. So this is approximately 1.98. And that makes sense because it's smaller than 2. Because we saw that 6 to the second power would give us 36. But that's a little bit too high. So we know our answer has to be a little bit less than 2. So 1.98.